Here we are going to discuss about the impact of jet. Impact of jet. Before starting the topic impact of jet, we are going to see the various types of it. So let's say the impact of jet on a fixed surface or the moving surface. First we focus on impact of jet on a fixed surface. When we say the impact of jet is on fixed surface, it has a two flow type. The flow may be normal, flow may be tangential. For the normal one, it is vertical plate, inclined plate, or curve plate, or the curve surface. For the tangential one, it is symmetrical curve surface, unsymmetrical curve surface, or parallel to the x direction. These are the types when the impact of jet is strikes on a fixed surface. Normal, tangential are the direction of the flow. In a normal flow, we have the vertical, incline, and curve plate or surface. In tangential, we have the symmetrical curve surface. It may be the asymmetrical curve surface. It may be the parallel to the x direction surface. So first we see the jet striking normally on a fixed flat plate. Let's consider the one plate. Its facts uh, is a fixed plate as is shown. This will be the fixed plate. This symbol is shows the fixed one. Let's a jet of water of area a meter square of cross sectional area a meter square strikes on a fixed flat plate normally with a velocity v meter per second as shown in figure. Here the one vertical flat plate which is fixed one, on that a jet is impact through the nozzle with the cross sectional area a, velocity v, and the outlet velocity is v meter per second. Thus inlet and outlet velocity are same, as we assume that the surface is very smooth. That's why the inlet and outlet velocity is same, right? Our aim is to calculate the force exerted on the plate. This is the normal plate, the impact of jet in normal direction. Let's say this will be our x direction. So we can calculate Fx is equal to mass into change in velocity in the direction of x, because jet is flow in x. So what will the changes happens in the velocity is also in a x direction. That's why we say Fx is equal to mass into change in velocity in the direction of x using the impulse momentum principle. So the mass, the amount of the mass enter or strikes on a plate is nothing but rho a v, because the same amount will be impacted through the nozzle. So we can say mass is equal to rho a v. Change in velocity is nothing but the initial velocity minus final velocity. So the initial velocity means the velocity of jet before striking the plate, and final velocity the velocity of jet after striking the surface or plate. So the initial velocity is nothing but the v, because this amount of with the velocity v meter per second jet is coming from the nozzle. So we can say initial velocity is v minus final velocity. At this point when the jet is strikes on a plate, the final velocity at this point is 0. That's why we can say this 0, or in other words we can say as plate is not moving, the final velocity is 0 1. So Fx is equal to rho a v square in terms of Newton. So we calculate the force exerted in a x direction or force exerted in the direction of the jet. As we know, the maximum force apply in a normal direction, so our aim is also calculate the force exerted in a normal direction. When we see the diagram, it's clearly mentioned, it clearly shows the jet is coming in a x direction, it's normal to the plate. So that's why Fx is equal to Fn. We take that will be directly says rho a v square is the force exerted in a normal direction. Now the second case, when the jet striking on an inclined fixed plate. Jet striking on an inclined fixed plate. Let's consider the one inclined plate which is fixed one. The jet is coming through a nozzle and strikes on the plate and move with a velocity v meter per second. Let's say this will be the v meter per second. Okay, at an angle theta. At an angle theta. Okay, so the jet is strike to the inclined plate at an angle theta. The plate is being ideally smooth. For the ideally smooth, the outgoing jet leaves the plate with the same velocity v. As we consider the plate is very smooth, so it will be leave the water with the same velocity v. As previous says, the jet exerts the maximum force on a plate only in normal direction. So our aim is to calculate the maximum force. So Fn, normal force, is equal to mass into change in velocity in a normal direction to the plate. Now the direction is normal direction to the plate. Before finding the Fn, the main part is that the velocity v is coming from the nozzle. That's why we resolve the velocity component v into the two components like normal and tangential direction. These are the velocity component of v. So we resolve this one as shown in figure, or the one inclined plate on which the jet is impact with the velocity v. So we take the one normal component, one normal component and one tangential component. As this angle is theta, so we can easily say these two lines are parallel to each other, so this angle is also theta. Okay, so the Fn is now nothing but mass into change in velocity. So Fn is mass is rho a v, mass coming from the nozzle, in bracket initial velocity minus final velocity. So initial velocity, the force exert in a normal direction, so that means the component of velocity in a normal direction is v sine theta, which will be exert on a plate in a normal direction. So that's why the initial velocity is v sine theta, as plate is not moving and the final velocity is 0. Okay, so we can say Fn is nothing but rho a v square sine theta Newton. But if you want to calculate the forces in x direction and y direction, as the jet is move in a x direction, so that's why the force exert in a x direction, we have to resolve the Fn component in xx and yy direction. So we resolve the Fn component in xx and yy direction. For the resolving, we know this will be the angle theta. So Fn force act in a normal 90 degree. That's why this angle is also theta. So we can say Fx is nothing but, now Fx is equal to Fn sine theta. We already calculate the Fm, put the value, we get rho a v square sine square theta. Same way Fn is equal to, Fy is equal to Fn cos theta rho a v square sine theta into cos theta. Now the resultant force is nothing but the square root of Fx square plus Fy square. Is it a magnitude? And the direction of resultant force is tan psi is equal to Fy upon Fx. So in this way we have to calculate the normal force exerted by the jet on a plate, the force exerted by the jet in x direction and y direction, and the resultant force of x and y component, and the direction of the resultant force. Now the third case is the jet is striking normally on a fixed curved surface. Let's assume we have the fixed one curved surface. Okay, the jet is striking in a normal direction with the area a meter per square with a velocity v meter per square. Let's assume the angle of the vane is theta. The angle of the curved surface around the x-axis axis is theta 1. Okay, now after striking, the jet is deflected. Let's assume the surface is very smooth, so the after deflection it will be move with the velocity v. Okay, with the v. Before proceeding further, as v is curving, before proceeding further we have to some one of some sign conventions are there. These are the sign conventions are there. Okay, the velocity and the velocity component in the direction of the jet shall be positive, where in the direction of the jet. That means your jet is coming. I said your jet direction for this one is this one, the jet direction v, right? The jet direction is v meter per second. If I take the velocity or velocity component in the direction of the jet, in the direction of the jet, then it is positive. If opposite to the direction of the jet, then it is negative. If it is opposite, that means when same direction, velocity or their component take as a positive, when opposite, velocity or their component take negative. Okay, now as a jet is impact on a curve, when it will be deflected through an angle theta and leaves with a velocity v. Therefore we have to take the components of velocity v in xx and yy direction. So we put there v sin theta and v cos theta. These are the two components. It may be represented in this way, or sometimes in some books we have to reference this way also. Both way are the same one. Okay, and follow anyone. So we can say the components of velocity is v cos theta and v sin theta. Now our aim is to calculate the force exerted in a normal or in a x direction. So we can say Fn is equal to Fx, because here force in a x and force in a normal direction are same. Again mass into change in velocity. So initially mass is rho a v. Initial velocity minus final velocity. Initial velocity means the velocity of the jet before striking. So it is v. So we can say the initial velocity is v, minus final velocity, the velocity of jet after striking. After striking it will be deflected, right, through an angle theta. So we can say the force exerted in a x direction or normal direction is nothing but the v cos theta. So that's why the final velocity is v cos theta. But as per the sign convention, as the direction of the jet is this one and the component is directed opposite to that one, so that's why we take here minus sign. As per the sign convention, as their component opposite direction, the change in jet shall be negative. So this minus minus get plus, we get common, so we get rho a v square 1 plus cos theta. Thus will be the force exerted in a normal direction, or we can say in a x direction. If we put theta is equal to 90 degree here, then what will happen? Cos 90 is nothing but 0, so we get rho a v square, which is exactly similar to our case in a flat vertical plate. This will be the rho a v square. Okay, now we have to calculate force Fy. So Fy is nothing but here Fy, if we see at the inlet triangle, there is a no force or the velocity, no velocity or any velocity component in y direction. So the initial velocity is 0, and in y direction at exit it is a v sin theta. So we put Fy is equal to mass rho a v 0 minus v sin theta. So we get minus rho a v square sin theta. Here this negative sign indicates that the direction of Fy is opposite to that of v sin component, due to which it is generated. It's not the negative one in magnitude, but the direction of the v sin theta is opposite one. So that's why that negative signs comes in picture. Again same, The resultant force is nothing but square root plus Fy square, and the direction is tan of psi Fy upon Fx.